Right, hello. I'm Marco. You already know me, probably. I'm annoying here people at work, in Bristol in general, since a while. I'm known as Acramius on GitHub. I work on a lot of open source projects, waste time mainly. If you don't know that, then this is my avatar. Again, you may recognize it or not. Work for a company called Rove. We're software consultants. And I'm contributing actively as a team member in the Zen Framework team and in the Doctrine team. So I was going to cancel all my talks generally, but and instead I wanted to play Kung Fury, which doesn't load here because Wi-Fi doesn't load right now. But Kung Fury is 36 minutes and we don't have time for that. So I'm talking about extremely defensive PHP, and that is because I'm an extremist. I became an extremist, and that is mainly because I maintain way too many projects that do too much, okay? Because everyone wants his nice little feature, okay? This is the feature creep, exhibit 1, okay? Probably know these guys, the Lonely Island, I think. Okay, so it's about aggressive practices. These practices are not for everyone. They're good for long-lived projects. They're good for open source projects because once you released it out there, somebody's going to use it for years you don't know. So defensive coding works nicely for that. So know your limits. This stuff is not necessarily fitting your project, and that's perfectly fine. If you don't like these practices, don't apply them. And in general, please be very considerate about what you released out there. Okay, you don't need to release every piece of software that you write. Just keep it for yourself, okay? Don't show it to everyone. It's like, I'm not gonna do analogies, okay? So let's start in a very bold way. You are dumb. I'm sorry, no, I didn't mean you. I'm sorry. I am dumb, okay? Now, well, we are dumb. Everyone is dumb, okay? Everyone gets a dumb. And that is very simple. We are animals. We are doing mistakes. We work with the context what we have. As Jakob was saying before, we don't know what we are going to write in our code after 3 months of discovering features and things that our clients want. We don't know it. So we don't, and by the way, those who say that they're not dumb, they're the dumbest, so, because they don't realize it. So does anybody know here what defensive driving is? Hands up. Okay, a couple of people know it. Defensive driving is pretty much driving assuming that others will do mistakes. Okay, so the idea is that you keep 3 seconds of distance in speed, depending on the speed that you have. You always assume that something may cross the road at any moment. You always be careful about what is happening. You always assume that somebody may just cross the road even if there's a red light, okay, on their side. So defensive coding is pretty much like defensive driving. You are cautious about everyone else's code, which means that you code your code so that they don't break it. Okay? You are cautious also about your own code because you are going to reuse that code sometime, and then you're going to git blame 6 months later and say, oh crap, who wrote this stuff? Okay? And that's going to be you anyway. Some references, books, boring, boring, skipping. Okay? These are recycled slides, so I'm just going to skip. There's some concepts that are very interesting from the industry, specifically for industrial design. There's this concept called POKA YOKE. POKA YOKE pretty much means avoid mistakes, okay, and foolproofing. I don't remember if one of these words actually means dumb or something like that, but the idea is very simple. You build something so that you can use it only in one way, and nobody can do it wrong, okay? This is an example of good design. I guess everyone knows what this is, RJ45 adapter. Anybody here ever managed to plug it in the wrong way? Upside down. Anybody ever built an ether killer? Maybe that. No sysups here? Never tried 120 volts? Okay, plug to this. It's fun, yeah? All right, this one is POKA YOKE. There's only way to plug it in. This one is actually quite bad design. I mean, this exists in a 4-dimensional space. You plug it in, doesn't work, turn it, plug it in, doesn't work, turn it again, works. It must exist in a 4-dimensional space. So this may not be such a good design. Okay, so let's make another couple of concepts clear. Okay, anybody agreeing with this? Fine, right? Nope. Okay, code is not reusable. Code is absolutely not reusable in my opinion. Code is crap, like 90% of everything. This is Theodore Sturgeon talking about books pretty much. He says that 90% of all literature of some category, can't remember which one, is crap. And I pretty much agree. Code is crap. What is not crap now is going to be crap later on, okay? Doctrine 2, pretty much everyone likes it to some degree, and we as internal developers hate it, okay? Just to give you an example. Okay, abstractions are reusable. Code is not reusable. You don't write crap, so don't write code in first place. That was my first suggestion for defensive coding. Simply avoid writing the code until you know what you need. So you code for your use case, don't code for your reuse case. Don't start writing classes that solve many, many different problems just because you think that you may have these problems. Figure out first what you need, actually. So, skipping over this kind of concepts, I'm going to actually go into some practices. I'm going to make some very, very wide assumptions. I'm assuming that there's solid code already. So everyone is writing perfect code here, right? I'm going to assume that as a start. I'm going to assume some object calisthenics. Does anybody not know what object calisthenics is? Just a hands up, no problem with that? Okay, look it up. If you need, just poke me later on. I can give you some references. It's a very interesting topic for you. Okay, first of all, start by making state immutable. You prevent any state leakage. You reduce bugs by reducing moving parts. How many bugs have you tracked down because a property of an object was having wrong state? Okay, so you avoid changing state. Once the object gets instantiated, you pretty much have that state. Once you have that variable, you have that state. PSR 7 gets it right. It's actually the new HTTP message interface. And it helps a lot. What about performance? We don't care. We measure, measure, and measure again. And it's only relevant if you reach some actual mathematical measurement and you actually figure out that your operation is going to be repeated enough times to be relevant for the problem of performance. Immutable state means also no setters. Okay, so you avoid having any setters at all. Setters don't mean anything in first place anyway. You're just changing something. You're not interacting with it. You're just setting things. What does that even mean? In a card game, you don't set the current card. You play the card, okay? You don't set the current card on the table, okay? And since we removed setters, we made state immutable, we can reduce everything to constructor only. That's the only point where we are going to change our state of our objects. All the rest is pieces that don't move. So we're making a big block of things that actually, when you construct it, it kind of sticks together. It's like Lego, okay? You stick it together, it's going to stick together. And it's like Technic versus Lego Basic, okay? Try making an airplane with Lego Basic and then make it fly. And you'll see all the pieces falling aside. You make it with Lego Technic, then it's going to stick together. Okay, that's the idea. Since we have only constructor as the entry point, you don't have any uninitialized properties. Internal state is going to keep stable. The object is immutable. Optional dependencies are a concept that doesn't really fit in this way of seeing it. So we have the typical case of a DB connection here, and we're constructing it with some parameters, probably string, DSN, maybe a PDO object, and so on. And then we're going to create a set logger. Okay, we say no setters, assuming that there is a set logger there, and we're assuming that the logger may also be null. We are pretty much coding around it, and what I see often is that people just skip, they check, oh, is this property null? Then don't execute this piece of code. No, optional dependencies don't exist. You're just hiding a trap there. Okay, you're hiding bugs and conditionals and tests that you have to add to this. Instead, just make the dependency required all the time, and if you don't need it, just inject a fake logger. This is a null object pattern. This object doesn't do anything. Okay, no setters, constructor only, immutable state, no uninitialized properties, no public methods that you don't need, okay? Unnecessary means that you can find any other way to write it. You can simplify to the bare minimum, okay? If you can find another way, you don't need that public method. If 2 consecutive method calls mean something, then you probably have a single method call with a different meaning. It's hidden there. You have a hidden abstraction there, as we were saying before. So a public method, this is interesting, is like a child. Once you've written it, you're going to maintain it for the rest of its life. Okay, that's actually very true. Stefan Priebsch at PHP Brno last year. Very, very true, actually. So when you write a public method, think twice before writing it. Avoid logic switch parameters. This is something that I see a lot being done to save a couple of lines of code. We had that today in the office as an example. We wanted to add a functionality, and we thought about adding a parameter to a method. And it does something like this. So we have a spammer class. No, we're not writing spammers at the office, okay? So we have a spammer object, and the spam method allows us to opt out, okay? By default, it does say false, so it's an actual illegal spammer. So this actually means that we have 2 operations that are just hidden. So we have a spammer instead that has a send illegal spam, no flag there, and then send apparently legal spam because they still think that they can send you emails that is legal. Okay, so you just remove the parameter, get rid of it, no decision path, much simpler. All states should be encapsulated. You don't allow any others to read anything from your objects until strictly needed. There's no behavior otherwise. You're just allowing them to read things. So that's actually interesting. Can anybody spot the bug here? Except that we are using a setter. What is the problem with this piece of code? You saw the talk. You're cheating. Does anybody know what is wrong here? Yes, it's passed in by reference. Okay, so the datetime object here, last refresh, is passed in by reference. This means that whenever it gets in my object, there's still state leaking outside of it. That means that, okay, and the examples are stupid on purpose anyway. Whenever I set the current time, I get the date time, bank account 1, set last refresh. Okay, this setters again, I'm sorry. I just couldn't be bothered making better examples, sorry. So stuff happens in between, and then sometime later, somebody does current time, set timestamp, a timestamp. And suddenly, we change the last refresh time for both bank accounts without even realizing it. We have leaking state across different boundaries, and it's actually a big problem. This happens a lot of times. So to solve this, you pretty much just either clone any state that is passed in by reference. As we said before, like with pure functions, you pass by value, never by reference, pretty much. Very much applies here as well. It's just that we're dealing with state. We're still moving stuff around. Or you use an immutable implementation of that kind of datetime object. So you pretty much rely on this other object being immutable, but you still should clone here because you can't really rely on the implementation being immutable. Same thing for the constructor. Constructor has the same problem. So you still need to clone here. And another thing that I think is really relevant is that external access and state leakage also means subclasses. Okay? Subclasses are an external accessor to your current scope. Okay? It is the same instance, it's the same object, but it's a subclass. It's a different concept, and you have some state leaking through different boundaries even here. So you make it private, make private properties by default. It's very simple. Symfony does it right here. Okay, Symfony has been doing it right for a long time now. And to be honest, Zen Framework has been doing it wrong for a long time here. And all right, I'm sorry, I'm running through things, so I'm probably just skipping ideas and concepts here that I would otherwise elaborate a bit more. But you can ask me any question later. Beer makes it easier, okay? So assert a lot. You expect strict things. Okay, strict invariants, you expect to return very strict things. So here I have a very horrible code example. It's horrible, but it works. So we have a train object, and the constructor accepts an array of wagons. So I'm not going to blindly assume that every wagon in that array is valid. So what I'm going to do is, and this is just PHP 7 syntax, so I'm going to create a closure with a splat operator here, well, a variadic parameter, and I'm using a splat operator to explode the wagons and pass them in as parameters here. So this pretty much results in a nice fatal error in case of one of these wagons not being a wagon. So then pretty much this ensures type safety. It's a very barbaric way of writing an array with a type. So this only works on PHP 7, but in general, you pretty much assume on anything that can be a moving part that you get given, you do assertions everywhere, okay? There's a library for this, so you don't have to write these horrors that I did here. I just was bored. Just use this one. There are other forks of it if you don't like this flavor, but this is something that you can pretty much use everywhere. So just go wild with it. I'm also writing a library called strict PHP. It's going to be interesting, but I still didn't release it. And it's kind of around the same concepts, and verifying that state pretty much revolves around the rules that you define for it. Okay, so we have strict checking on what you get given, so that means no mixed parameter types. So here we have a bad example. So we have a prisoner transfer request. Okay, we're working for, I don't know, enforcement agencies. And we have an access level, and we are going to approve this prisoner transfer request with a security level. And the security level may be false, true, null, 10 if special cargo is needed, 20 if high security is needed. What the, what? All right? That's really just messy. So what we do is we take anything that has like moving things and encapsulate it and hide it behind these things. Anybody knows what that is? Very simple. What is the prisoner security level? Come on. What can it be? It's a value object. It's a value object. Okay, so this object here is just containing a value and enforcing some strict rules around it. Plus it has some API that may help me. So value objects for the win. They ensure consistency. They pretty much ensure that when I move this value around my system, it's going to stay consistent. Nobody's going to change it because it's immutable. Value objects are not necessarily immutable, but I think if you don't make them immutable, you're pretty much missing the point. They simplify data validation in general. You have a valid value, okay? You have a new email address. I just pass it around in my system. I don't need to revalidate it in every layer. Type safety and the language ensure that this value is going to be valid for me. And you don't need to revalidate in every layer. That's the actual point. You don't have a string of mixed length, and every layer has to check if this string is an actual email address. No mixed return types. So we said no mixed parameter types. Why should I return a mixed return type and make it complicated for the consumers of my API to actually use the API? And again here, if you have a mixed type, if you have something more complicated, just return a value object here as well. Okay? No Fluent interfaces. This goes kind of against the previous talk. Fluent interfaces, they have various problems that I documented, wrote a blog post about it. But here's the problem. Does anybody recognize what the problem here is? These are 3 valid use cases for the same exact API. Which one is correct? Which one has a bug? They're all correct. They all work. Okay? Does anybody know what this was? Yeah, I know I have the syntax error. I didn't fix it. Oh, gosh. Yeah. Don't write slides at night. Okay. Anyway, so the problem here is, and it goes back to what I was saying before in the principles, is that this doesn't follow POKA YOKE. You have 3 ways of doing the same exact thing. Why do I need that? Just make it one way. That's it. Just do it this way. Void is a perfectly valid return type signature. I'm not going into detail on the other disadvantages of Fluent interfaces. Monads, yes, they're useful, but it's a functional thing, and it's actually the advantages are in more like compiled languages that understand tail recursion and compiling other aspects of the language. Here, it's more about having one approach for doing something, not more than one approach. You don't need it, okay? It's just going to make it more complicated. Okay, and the other one is make classes final by default. Does anybody use final here? You started. Ah, nice. Ah, there are some hands up. That's good. All right. Make classes by default final. As I said, a subclass is a different boundary. You are solving a different use case. Okay. You're kind of going against this rule of not coding just for the use case. You're trying to code for the reuse case. Okay. And extending classes brings a lot of very horrible dependencies and so on. You don't really want to do that. What I have as a good rule of thumb is, think about it. Take the class that you're writing, make it an interface. Okay, if it doesn't have an interface, make it an interface. Okay, now take that interface and extend the interface. Does it still make sense? Are you actually adding some meaning? If you're not adding any meaning, then you don't need extends. Okay, it doesn't make sense to use extends. Extends is an operator that gives you more meaning. It allows you to add more meaning to some concept that you're trying to extend. It's not about solving a problem, it's about how you design around the problem. Okay, how you build the problem before you try solving it. Solving it is the implementation. So if you can't extend the interface, then it doesn't make sense to extend the implementation, right? There's a blog post also there. Lots of ranting, lots of people commenting, and you want them final, you can't mock them. I have answers for that as well. Okay, ensure deep cloning. These are actually things that come from old Java books. Interesting though. So whenever you clone an object, the interesting part is that you're not going to clone anything that is in this object by reference. You're just copying the references. This means that you have the same encapsulation problem that we had with the bank account. You clone the bank account, you didn't consider deep cloning, now you have two bank accounts, changing one changes the other. You're going to have some problems there. So cloning requires you to understand the encapsulated state, okay, and that's kind of broken. You have an operator that has access to encapsulated state. This is something that the language gives you, but out of the box. So what you can do is you can consider, since it's a contradiction, you can consider disabling it, maybe. What about this? Okay, you have a class human, and you have public function clone, and you have a domain exception. Why are you even cloning me? It's currently legal. Okay. Maybe they're going to make it legal sometime, but right now it's illegal. Okay, it's not an allowed operation. Okay, and somebody else may clone your object, and they may have a bug, and then they open an issue, and they say, yeah, I can't clone your objects. And you say, why are you cloning them in the first place? And you didn't enforce it. Same for serialization. Serialization requires a lot of understanding of how your object works, what is the runtime, what is the life cycle of all the dependency of the object, of the sub-dependencies, and so on and so forth. So is it really serializable? Can you really serialize your object? Do you really know the life cycle of every single dependency in your object? Okay? Can you serialize an object and be sure that when you unserialize it on the other side, all the current invariants are still true? It may be that other objects require to work in the current request. It's a violation, obviously, but still, it's an invariant that you're breaking. And you don't know if these other objects rely on that. So is it even supposed that you take this object and store it somewhere? Maybe not. So maybe just throw an exception here as well. There's this magic sleep. Nobody should actually use it. But it's good to make it just fail and crash badly. So if somebody throws the my awesome thing in the session, he's going to have a bad day, and that's actually good. So he doesn't unserialize on the other side and have a much worse day. So serializable, serialize only what is actually serializable. If you design it to be serializable, then you're going to design for this sort of problem. Otherwise, just simply disallow this. Unit testing. I'm actually going to see if I can still steal a couple of minutes. OK, test all scenarios. Yes, all of them. This means bringing the CRAP score of your tests. You have to look it up. It's here, I think. Can I hover here? Yeah. Change risk anti-patterns, because I don't remember it either. OK, bring the CRAP score below 2. This is pretty much how many tests there are for your paths in your code. If you bring it below 2, that means that pretty much you tested every path. That's pretty much what it means. It will make you cry. OK, you will implore for less features, and you will love having less features. If you start testing like this, you're going to really, really, really be very cautious about what you are doing, what your dependencies are. Here's an example. You have an out service. Out service has an authenticate method with the credentials, which is a value object here. You have a Boolean return value, and you throw an invalid argument exception, incompatible credential exception, and unavailable backend exception. And you have my login, which has the out service as a dependency, and then the login executes some code. If the authentication succeeds, then it just executes some code and returns true. Otherwise, it returns false. OK? So what can happen here? How many tests do I have to write for this code? 5. That's a good one. That's a good answer. So we have indeed to write Boolean true, Boolean false, invalid argument exception, incompatible credential exception, unavailable backend exception, and 5 tests just for this little amount of code. So that makes you think about how many things we don't consider when just including a dependency in our code. There's so much that can go wrong. OK, to recap, these are just suggestions. There are many, many more of these rules that you can take in consideration. You trust nobody's code. Everyone's code will break. Your code will break as well. Make your code so defensive that nobody can actually use it in the wrong way. So you reduce features to the bare minimum. You prevent feature creeps. You ain't going to need it anyway. Strict invariants and strict return types as well. So you wait strict, return strict. And that's it. Thank you very much. Any questions? Oh, and by the way, copy-paste is better than extending. Sorry, yeah. Sorry?
How do you get your crap code down to 2? That's one if.
Yes, pretty much. You have to write one test for every point in the cyclomatic complexity, pretty much. And then you got the CRAP score to 2. That means that your code pretty much has to go down there.
So do you have lots of functions in every?
Yes. Yes. Let me see. This is just the project, Doctrine Instantiator. Let me see. It's just single class, I think. Is this SRC? Yes. Instantiator. It's pretty much code that has a couple conditionals maybe per method. So you have different methods. Every method has maybe one conditional. Well, this one has more because it actually is catching serialization errors. So you need to use PHP's nice error system. But you see pretty much every method is just really, really small. Like every one of those methods has maybe 4 tests this way. Any other questions? Sorry.
I just wondered what font it was that we used on the
The default one. I don't look up fonts. I don't even know what a font is. Sorry. You can download the slides and clone them on GitHub.
The example you were given for type to raise, for a certain type to raise, that immediately invoked function expression. Is that PHP7 or can you do that already?
That is PHP7. So
So you can't do an IIF.
where is it? This one.
Yeah.
So what I'm doing here is I'm defining the function and calling it as I define it. This only works with PHP7 because of the new parser. Any other questions? All right, beer? Right?